Hello everyone. Let's start a new questions, which is about supervised image classification. What is the steps involved in supervised image classification during we perform an analysis work? Supervised image classification. Supervised image classification is the process in which a machine learning algorithm assigns a label or class to each pixels or region in an image band or training data. In supervised classification, the algorithm is trained using labeled images, where the categories or classes for each pixels or regions are already known. The classifier then use this knowledge to classify new unseen images. In classified image classification, the key idea is to be infer a mapper from the input features, typically the pixel values, to the class labels. These classes could represent objects, land use types, or material depending on a context. Example: forest, roads, buildings, water bodies, etc. in uh, satellite imagery. Now, what are the steps involved in supervised classification? First is the training data collections, ground truth data. We call it as a ground truth data. The first step involves selecting the preparing training data. This is a set of image or regions of interest where the class labels are already known. These are called as a ground truth data. Example: in satellite image classification, ground truth data could be gathered by taking real world surveys or using pre-existing maps where land use is already classified. Features: extractions. Each pixel in an image has certain characteristics like colors, textures, intensity, or spectral bands. These characteristics are called features. Features extractions refers to calculating these numerical values that represent important properties of the image. Features can be spectral information, RGB or infrared, etc., textures, shape, and spatial informations. Third is the training, the classifier. A classifier is trained using the label data. Popular classifier including decision trees, support vector machines SVMs, random forests, neural networks ANNs, and k nearest neighbor is a KNN. The training algorithm looks for a pattern in the training data and learns how to differentiate between the different classes based on the features provided. Classification of the entire image. Once the classifier is trained, it is applied to classify all the pixels or regions in the input images. Each pixel is assigned to a class based or learned models. The classifier labels each pixels according to the class. It most likely to belong to the based on the features extracted. Accuracy assessments. After the classification process, the results are evaluated by comparing the predicted labels with the ground truth data that was not used in the training process. Confusion matrix. A common tool used to assess a classification's accuracy. It shows how many pixels are correctly classified and how many were misclassified for each classes. What are the overall accuracy then the percentage of the all pixels that were correctly classified. There is also kappa coefficients, a statistical measure that accounts for the possibility of a current classification by chance. So we can see these things during the RGIS process analysis process in RGIS software. Post processing optional. Sometimes additional processing is done to improve the classification results, such as smoothing and filtering to remove noise, or analyzing majority filters to adjust misclassified regions. Spatial filtering used to smooth the classified image, helping to eliminate isolated misclassified pixels. Seventh is the output generation. The final output is a classified image where each pixel or region is labeled with a class. This classified map can be used for further analysis in applications like land use analysis, object detections, or medical imaging. Summary of the supervised image classification step. First is the collection of data, then feature extraction, then training the classifier, then classification, then accuracy assessment, then post processing, and last is output generation. Supervised classification is widely used in applications like remote sensing, medical imaging, object recognitions, and environmental monitoring because it is a leverage human expertise in assigning labels, making it highly reliable when good training data is available. So this is about a supervised classification. Thank you.